This is a introduction to modular arithmetic. So I've just completed a modular arithmetic table, and see if you can pause the video and explain where the answers came from. You can ignore the blue box here. So pause the video and see if you can come up with the answers. Okay, so hopefully you've paused the video and realised that, for example, 4 multiplied by 4 in normal arithmetic is 16, but on division by 5 gives a remainder of 1. The same is true for 2 multiplied by 6 on division by 5 gives a remainder of 1, and 3 multiplied by 4 on division by 5 gives a remainder of 2. Okay, so let's look at another quick example, and then we'll explain the maths to do with modular arithmetic. Okay, so I think the best example to give is to use something which we see every day. That something is a clock. So let's do the clock, and we start off with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I hope you realised we're working in mod 12. Okay, so I started off at 0 because when we divide 12 by itself, we get a remainder of 0. Now, I think a really good analogy for modular arithmetic is wrap around numbers. Also, it's referred to as arithmetic of remainders. Okay, so let's look at an example. Let's do 9 plus 5, and we want to work in mod 12, and this means congruent to. Okay, and in this context, congruent to means has the same property on division by 12. I'm just going to repeat that. In this context, congruent means has the same property on division by 12. Okay, so let's look at these wraparound numbers. So we start at 9 and we move in 5 spaces. 1, 2, 3, 4, 5, and we arrive at 2. Now, 9 plus 5 gives 14. On division by 12, you get a remainder of 2. Mod 12. That's another way at looking at it. Let's do one more example. Let's do 11 plus 6. Now, under normal circumstances, normal arithmetic, 11 plus 6 gives 17, but we're working in mod 12. So we start off here, and we're going to move 6 spaces. 1, 2, 3, 4, 5, 6. We arrive at 5. Another way to look at it is that 17 on division by 5, on division by 12 rather, gives a remainder of 5 mod 12. Okay, so sticking with the clock, let's have a look at the residues. Now, the residues are the allowable numbers, the allowable remainders on division by 12. So the residues simply are going to be all the numbers 1, 2, 3, to 11. Because if you get a remainder of 12 or greater, obviously the number of times 12 goes into it increases. So you can't have a remainder, an integer remainder, 12 or greater, because 12 divided by 12 gives a remainder of 0, which means we need to insert a 0 into our residue. So let's take a closer look mathematically at congruence. Now, if two numbers are congruent, we write this as A is congruent to B mod n. Now, congruent means, in this respect, has the same property on division by n. I'm just going to repeat that. In this context, congruent means has the same property on division by n. So let's write these things down. This is congruent to we didn't want that there. Congruent to, and we're going to say that A and B are integers, and we're going to say that n is a positive integer. Also, we can say that A minus B must be equal to Kn, where K is an integer. Okay, so let's have a look at some examples. I would like you to complete the multiplication table mod 3. Okay, so the allowable numbers should be able to work out at 0, 1, and 2. And because we're dealing with modular multiplication, we put a little circle around there. So you're going to have 0, 1, 2, 0, 1, 2, and see if you can complete that table. Okay, so it's going to be a pretty short one. We're going to get 0, 0, 0, 0, 0. 1 is allowed, 2 is allowed, 3 is not allowed. We get a 0, and 2 times 2 is 4. On division by 3, we get a remainder of 1. And if you can see, this fits with the residue 0, n minus 1 being the last term. 3 minus 1 is 2. Let's look at a more complicated table. Let's do mod 6. Mod 6, and I would like you to write the residues of mod 6 for me. Pause the video, please. Well, the residues of mod 6 follow the formula n minus 1. Well, that gives a residue then of 0, 1, 2, 3, 4, 5. And let's do the multiplication table. 0, 1, 2, 3, 4, 5 0, 1, 2, 3, 4, 5. See if you can pause the video and do the multiplication table for mod 6. Okay, hopefully you've done that. So we're just going to get 0 here, 0 is here. 1 times 1, 1 is allowed, 2 is allowed, 3 is allowed, 4 is allowed, 5 is allowed, 2 is allowed, 4 is allowed, 6 is not allowed. We get a remainder of 0. 2 times 4 is 8. 8 is not allowed, but we get a remainder of 2. 10 is not allowed. We get a remainder of 4. 3 is allowed. 6 is not allowed. We get a remainder of 0. 9 is not allowed. We get a remainder of 3. 12 is not allowed. We get a remainder of 0. 15 is not allowed. We get a remainder of 3. 4 is allowed. 8 is not allowed. We get a remainder of 2. 12 is not allowed. We get a remainder of 0. 16 is not allowed. We get a remainder of 4. 20 is not allowed. We get a remainder of 3. 5 is allowed. 10 is not allowed. We get a remainder of 4. 15 is not allowed. We get a remainder of 3. 20 is not allowed. Okay, is this right? 15. Yeah, we get a remainder of 3. Okay, 5 times 4 is 20. Is not allowed. We get a remainder of 2. 3 6s at 18. 2. 5 5 is 25. Not allowed. We get a remainder of 1. Okay, so hopefully this is correct. So let's just look very quickly at our mod relation. So let's have a look at 5 multiplied by 4. Let's just circle this on the table. Okay, 5 multiplied by 4 is here. That is congruent to 2 mod 6. Of course, 5 times 4 is 20. 3 6s are 18. The remainder is 2. Now, I want you to write the congruency relationships for the 4-year, the 3-year, and the 0 here. Pause the video and write the congruency relationships. Okay, hopefully you've done that. So the 4-year is from 4 times 1. 4 times 1 just gives 4 mod 6. Okay, 4 is allowed because it's in the residue. The 0 here is from 2 times 3. Okay, that should be congruent to 2 times 3 is 6. It gives a remainder of 0 mod 6. And finally, we've got the 3. 3 times 3 is equal to 9. It gives a remainder of 3 mod 6. Okay, so let's just have a really quick recap and we look at something a little bit more advanced and that will give us a good introduction to modular arithmetic. Okay, so recap. If two numbers are congruent to each other, we can write A is congruent to B mod n. Well, if A and B are congruent mod n, we can subtract this and say A minus B is some multiple k of n. We need to define what values A, B, n, and k can take. Well, A, B, and K are any integer, that is to say, any positive or negative whole number. N needs to take a positive whole number. So let's do a little task. Let's work in Mod 17. And I would like you to work out the following numbers in Mod 17. 20, 25, and 30. Off you go, and pause the video. Okay, so hopefully you've done that now. So 17 is congruent to 3 mod 17. We must write the mod 17 in. We worked that out by 20 divided by 17 gives 1 remainder of 3. Okay, so 25 is congruent to, just get rid of this squiggle. 25 is congruent to 8 mod 17. Why? Because 25 divided by 17 goes in once and we have a remainder of 8. Okay, so let's put commas between these. 30 is congruent to 2 times 17 is 34. So we get a remainder of 13 mod 17. Okay, so let's just quickly have a look at this condition here. So 20 minus 3 is 17. And we can get a k, which is 1, and 17, which is n. So this is k, this is n. The same for 25 minus 8. 25 minus 8 is 17. And we get the same there. 17 is 1 and 17. This is k, this is n. Okay, and the same is true of 30 is equal to 13. 30 is congruent to 13 mod 17 rather. Okay, so let's just finish the video by looking at something a little bit more difficult. Okay, so we said that two numbers are congruent. A is congruent to B mod n, given that A and B are integers, but n needs to be a positive integer. We also said that A minus B is equal to Kn, that is A subtract B is some multiple of n. But we had a condition that k, let's get rid of this blob, that k is an integer. So k could be negative. Since integers have the condition that they need to be whole numbers, we have positive and negative whole numbers. We say that k is a member thing. Now, let's look at mod 5 and see if we can do some negative numbers. -2, -7, and -8. Now, we want to see what these numbers are congruent to. mod 5. Okay, so we need to write mod 5 in. Mod 5, mod 5, mod 5. Okay, so remember the condition. We need to subtract something from 3 to get a multiple of 5. Now, there are various answers. Remember, these are wraparound numbers. So one obvious answer here is -2 is congruent to 3 because -2, -3 is equal to -5, and that will give us a k of -1 and a n of 5. So this is k and this is n. Now, let's try and get a multiple of, let's put a comma here, let's try and get a multiple of 5. -7 is congruent to 13. Why? Because -7, -13 is equal to -20. And we know that -20 is -4 and 5. So this is k and this is n. Let's put a comma here. That's not what I wanted. Let's just get rid of this. Let's just get rid of that. Okay, so we were dealing with -7, and I said that that was congruent to 13. That was congruent to 13 mod 5. Why? Because -7, -13 is -20, and we're going to get a k value of -4 and 5. Okay, now as I said previously, we can have different numbers. These are wraparound numbers, so we can also say that -3 is congruent to 3. Why? -7, -3 is -10, and we're going to get a k value of 2 and an n value of 5. So, when you are considering congruence values, there are an infinite amount of values that these congruence relations can take because they are wraparound numbers. And that's a really, really important concept to understand. And just finish on mod 6. See if you can write down the residues of mod 6. And that is to say the possible values on division by 6, considering the remainders. Okay, so the possible values for remainders are 0, 1, 2, 3, 4, and 5. And let's do some arithmetic using mod 6. And remember that mod 6 are wraparound numbers. So let's 0, 1, 2, 3, 4, 5. And remember there's not 6 because 6 divided by 6 gives a 0 remainder. Okay, now let's consider some more negative values. Let's have a look what -3 is congruent to mod 6. And we're going to get, let's do two solutions to this. Two solutions. -3 is also congruent to another number. Okay, so what can we subtract from -3 to get a multiple of 6? Well, let's start off with the first multiple of 6, which is 6. So -3 is congruent to 3 mod 6, and we can do that by 3. -3 is -6, and we're going to get a k of -1, and we're going to get a 6, which is our n. -3 is also congruent to, let's get an 18, 15. And we can show that -3, -15 is -16. We're going to get a k of -3 and a 6. So this is a k and that's an n. So we can extend our number line then to include negatives. And I think that's all I want to discuss on this introduction to modular arithmetic. I hope you enjoyed the video.